Hello students, here is Divya Singh, Assistant Professor, School of Computer Application, PBD University. So now in this lecture, we see the global system of mobile communication, that is 2G. In 1982, the Conference of European Post and Telegraphs, that is CEPT, nominated a group called the Groupie Spatial Mobile, that is GSM, to develop a public landline mobile system that could operate across Europe with the objective of low mobile device and service cost, good speech quality, international roaming capability, ability to support handheld mobile devices, extensibility for adding new services and facilities, efficient use of spectrum, and compatibility with the ISDN. The group came out with the specification in 1990s and commercial system started rolling out in 1991. Today it has become a globally accepted standard for digital cellular communication. The developers of GSM proposed the digital communication system in an era when long cellular systems like AMPS in the United States and TACS in the United Kingdom were the dominant functioning models. The group relied on the advanced talking pace in digital communication and compression algorithm to match the speech quality signal to noise efficient and ensure optimal channel capacity utilization. The digital communication was also helpful in the meeting the ISDN capability in terms of the services offered and the controlling signaling used. Although since it is based on radio transmission, the support for standard ISDN B channel bit rate of 64 bit per second, kilobits per second in terms of bandwidth, the cost cannot be practically achieved. As with all the other communication, speech is digitally encoded and transmitted through the GSM network as a digital stream. It also supports emergency service where the nearest emerging service provider is notified by dialing three digits. The GSM system supports a variety of data services at rates up to 9600 bps bits per second. A GSM user can send or receive data to user on plain old telephone service, that is spots, ISDN packet switched public data network, and circuit switched public data network using a variety of access methods and protocols such as X.25 or X.32. The user of GSM do not require modem for data transmission or reception as it is a digital network. However, the interconnection between the ports and GSM network needs an audio modem. The GSM network also supports Group 3 facsimile ITU T T.30 through the use of the approximate fax adapters. Although very popular service supported by the GSM is the SMS, the service offers the bidirectional transfer of short alphanumeric up to 160 bytes messages. These messages are transferred using the store and forward paradigm. The SMS service can operate in the point to point mode where a message can be sent from one subscriber to another and the sender receives the acknowledgement of the receipt. The SMS service can be used to sell broadcast mode for sending messages such as traffic or new updates. These messages are stored in the SIM card for later retrievals. The GSM networks is also capable of supporting call forward such as call forwarding when the mobile subscriber is unreachable by the network. Call bearing of outgoing or incoming calls, caller identification, call waiting, and multiple party conversation. The objectives are low mobile device and service cost and the good speech quality. Next, now we see the GSM network consists of three major systems, that is the SIM in the mobile devices, or the base station substation connection, that is BTS and BSC, etc. And next, network subsystem, that is HLR, VLR, MSC, EIR, OC control, etc. The PS and this is connected with PSTN, ISDN, PSPDN, and CSPDN. The three stations are the mobile station, the base station subsystems, and the network subsystems. Now see the first the mobile station. In GSM network, the mobile station MS consists of the equipment of also offered, often referred to as a terminal and a removable subscriber identity module, that is SIM, in the form of a smart card. The SIM card has user specific information for accessing the subscribed services independent of a specific terminal. The SIM card can be inserted in any or the other GSM mobile equipment or terminals, and the user will be able to receive calls specific to that identity at the new terminals. It can also initiate calls from the new terminals and access and operate other services that have been subscribed by the mobile users. In essence, the SIM card offers personal or identity mobility. In the GSM mobiles, the mobile equipment is uniquely identified by the International Mobile Equipment Identity, that is IMEI, assigned at the time of manufacturing. The SIM card identity is independent of the IMEI. It uses the International Mobile Subscriber Identity, that is IMSI, for identifying the subscriber to the system, a secret key for their authentication and other informations. The independence of IMEI and the IMSI and the use of IMSI alone to identify the subscriber on the GSM network provides the personal mobility with regard to the mobile equipment. The SIM card also has a provision for protection against authorized use by use of the password or personal identity number, that is PIN. Now next is base station substation, that is second point. The base station substation is made up of two important components, the base transceiver station, that is BTS, and base station controller, that is BSC. The base transceiver station is typically a radio transceiver that operates within a cell defined by the power and the footprint of the antenna used. It deploys and communicates with the mobile station through radio link protocols. The large and dense cellular networks may deploy a large number of BTS. Thus, the requirement of the BTS are ruggedness, reliable, portability, and minimum cost. One or the more of the base transceiver stations operating in a cell are controlled by the base station controller. It manages the radio resources for the BTS radio channel setups, frequency hopping and transovers, handovers. Other on the other hand, the BSC is connected to the mobile service switching center, that is MSC. Now the last and the third one is the network subsystems. The MSC forms the core of the network subsystem. In the work like any ISDN and PSDN switching center and performs the switching of calls between the mobile users and between the mobile and fixed network users. In addition to the normal call switching functions, it also handles mobility management. The information on the registration, authentication, location, call handovers, routing in case of roaming over all handled by the MSC. In order to handle the mobile uses, information management and mobility issue, the MSC uses four databases, that is location register, visitor location register, authorization and equipment identity register. The home location register, that is HLR, maintains registration and the requirement administrator information for all the subscribers registered in the GSM network along with the current location of the mobile. The location of the mobile device is typically stored as a signaling addresses used by the visiting location register, that is VLR, associated with the mobile station. The home location register is often implemented as a distributed database through the logically there is only one HLR per GSM network. The home location register also, along with the current location and the other information of the VLR, is used for managing roaming and call routings. The VLR is typically associated with the MSC so that the VLR information about all the mobile devices currently located in the particular geographical area is controlled by the MSC. This simplifies the process of the location and signaling, as the MSC does not contain any information about mobile devices and thus only concentrates on signaling. The VLR contains an entry of all the mobile devices currently controlled in the area served by the MSC in which the VLR is associated. The VLR entry contains a portion of selected administrative information stored in HLR related to call controls and the provision of subscribed services. The other two registers are used for authentication and security purposes are spectral allocation. Each mobile device has a unique equipment identity called the International Mobile Equipment Identity, that is IMEI, provided by the manufacturer. Typical, it is difficult to modify. It, in the most of the cases, any attempt to modify the identity results in destruction of the equipment. The Equipment Identity Register, that is EIR, is a database that contains a list of all valid mobile equipments on the network where each mobile station is identified by its IMEI number. An IMEI is marked as invalid if it has been reported stolen or it not type approved. In GSM, communication happens in the encryption format using a secret key. The authentication center, that is AU, stores a copy of secret key stored in each subscriber the subscriber's SIM card, which is used for authentication and encryption over the radio channels. Spectral allocations. The GSM uses 25 MHz for the mobile device to base station transmission uplink and the additional 25 MHz for base station to mobile device, that is downlink transmissions. The International Telecommunication Union, that is ITU, the managing body of the international allocation of radio spectrum, allocated the bands 890 to 915 megahertz for uplink and 935 to 960 megahertz for downlink transmission for the mobile network in the Europe. It is the same allocation that was used for the wide variety for analog transmission system in Europe. The allocation of 25 megahertz or 25 megahertz for the analog systems had reserved 10 megahertz for future use. GSM networks were initially built using this 10 megahertz and later expanded to the full spectrum. Now, multiple access. The GSM network use a combination of frequency division multiple access FDMA and the time division multiple access, that is TDMA. The 25 megahertz of limited radio spectrum allocated for the use of GSM network is shared by all the users by dividing the bandwidth among as many users as possible. The GSM network divide up to the 25 megahertz radio spectrum in 124 carrier frequency channel that are allotted to a 200 kilohertz each. Each base station is allocated at least one or more carrier frequencies. Each base station uses TDMA by dividing the carrier channel into the time slots. The fundamental unit of time is this TDMA scheme is called a bus period and it lasts 15 or 26 microseconds or approximately 0.577 microseconds. Each 8 bus times are grouped into a TDMA frame, that is 120 to 26 microseconds or approximately 4.615 microseconds, which forms the basic unit for the definition of logical channels. One physical channel is one bus period per TDMA frame. The channels are defined by the number and the position of their corresponding burst period. All these definitions are cyclic and the entire pattern repeats approximately every 3 hours. The channel can be divided into dedicated channels, which is allocated to a mobile station, and common channels, which are used by the mobile station in the ideal mode. Now, thank you for listening.